Okay, we're live. Okay, so where I want to start today is we've talked about how you can encode numeric data in however many bits, and we've used basically 8 as our kind of running example case, although you can of course use more bits and if you want. So, but that's not the only kind of data that we'd want to be able to encode on a computer, right? So numeric data is obviously very useful, but there's way more than just numeric data. And what happened to you? Hat hair, okay, yeah. What other kind of data would we want to be able to store in a computer? Well, text would maybe be a logical next type of stuff to worry about. And so this makes for an interesting question. How do we store text on a computer? Or better put, how did somebody else 50 or 60 years ago decide to store text on a computer so that we can understand that system? And then also, what are the limitations of that system, if any? And so to motivate this, I thought we'd actually start with a clip from YouTube. How many of you guys have seen this movie, right? How many of you guys remember this particular scene? All right, well, let's go for it. And let me know if the audio is either too loud or not loud enough back there. Can you guys hear it? No? Okay. Hold on. Make sure the sound is actually coming out where it's supposed to be. Sound, play sound effects through, output, Blackmagic device, HDMI, okay, input for my AirPods. All right, let's try again. Oh, hold on. Okay, I've got the sound to max. Stand by, technical difficulties. Did you hear something? Okay, it's just I need to get the audio level up a little bit more. There we go. Okay. This is from The Martian. Okay, so you guys remember that scene? Now you do? Oh man, you missed the whole good part. No, we have other things to do. Um, all right, so let's take what he encoded, right? He encoded, or NASA encoded there, how alive. And they did it using a scheme called ASCII. So ASCII stands for American Standard Code for Information Interchange. Okay, and this dates back to what, 1963, right? So very early in the era of computing, and in particular, the 60s are kind of the very early in the era where computers are talking to other computers rather than just there being a computer and humans feed things in and get things out. So um, ASCII is not the only standard that came about in terms of how to define characters or how to store text information, but it's the one that's stuck. And for that, let's look at the code points, and they've got a nice little table down here. So there's the ASCII table starts with, well, sorry, first off, the ASCII table can store it was originally defined as a 7-bit standard, and then later we'll see it got extended slightly. But it looks like 7 bits, so just add an eighth zero to the left of everything to make it an 8-bit thing, since we tend to store stuff in 8-bit chunks. The first 32 of these 8-bit patterns are don't represent anything that's a printable character. Okay, so for example, there are um, two characters, 0A and 0D, that represent line feed and carriage return respectively. Okay, what the heck is a line feed and what the heck is a carriage return? Yeah. Yeah, it's something that we've inherited from the typewriter era. So how many of you guys have actually used a typewriter? Yeah? Did you have you used it for anything productive or you just found it laying around at your grandma's house when you were a kid and went bang 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 bang? Yeah, okay. So how does a typewriter work? You put paper into it, right? And then you type. And what happens as you type? The carriage, the thing, moves to the, well, this way is the right for you guys, moves to the right. And what happens when it gets to the far right? You have to move it back, but how do you know it's reached its limit? It makes a little ding, right? So guess what character number, I think 7 is? Character number 7 is the bell. That's the ding. Okay, so you can transmit to make a ding. And back in the day, right? So typewriters, manual typewriters, very quickly, people realized, oh, you could automate the typewriter and have a computer control it, and then you got what was called a teletype machine, right? So if you had, for example, you were transmitting a radio message, you could have the computer transmit it, and then the receiver would receive it and type as it went, right? So you could automate that process. Um, but yeah, so we've got the bell, we've got the line feed, we've got the carriage return, all of these sorts of things, or start of text, end of transmission, that sort of stuff was are characters. They're not printable, they're not letters or anything, but they're used to allow computers to talk to each other. And a lot of these are, of course, as I said, legacies of the typewriter and teletype era that live on to this day in computer code. Okay, so great. Also, then, what's the difference between a line feed and a carriage return? Well, the carriage return means to move the thingy back to the left. The line feed means to move the paper up one line so that you can type on the next line down. Right, and those are two different things on a typewriter, and hence they're two different character codes in ASCII. Yeah. You know what? Just to build some character, you know what we ought to do one day? We ought to just like remove all the computers from the library and just replace it with a bunch of typewriters and just say, good luck, have fun, guys. Right? Make you type all your papers on typewriters. Yeah. Yeah, it would be. It'd be entertaining for about 10 seconds. Oh, it'd be great for us. Like for weeks, it'd be entertaining. But for you guys, huh? No, I think she'd think it's funny too. We'd make sure she's on vacation that week, right? So, yeah. So actually, on the subject, then, how many of you have some of the longer serving professors that you're in a class with this semester, like Blix or Himsel or somebody like that? Ask them about their days of being a Wabash student when they had to use a typewriter. Okay. So yeah, just ask them about that. See what they have to say. Um, anyway, okay, so those are the non-printing things, and of course, what we're interested in is the printable characters, which start at number 32 decimal, or I want to pay attention. So there's 3 columns here. These are the numbers that are attached to each character, and they're written in 3 different formats. So we have octal, which is base 8, and nobody uses anymore. We have decimal, which is just normal numbers. And then, of course, hex is hexadecimal. And that's the one that I really want to concentrate on here. Because you guys are all great with hexadecimal now, right? Getting there? Yeah. Okay. So the beginning characters are mostly punctuation and stuff, including a space. Okay. Obviously, you can't print a space. It just means to move over one position. So we'll just write space for that. But then, you know, quotes and dollar signs and parentheses and the plus symbol and oops, the digits, right? So all of those characters are there, comma, dash, period, slash, numbers, and so on. And then for our purposes here, starting at 41 hex is where the oops, that is not the button I meant to press. All right, let me put this over here because I want to open up a text editor here. Okay, so let me save this, and I'll just save it to the desk. I'll just save it to my home directory. Okay, so the message from the Martian was, "How alive?" question mark, right? Okay, and there we see I just typed it out, "How alive?" And in the case of the question mark in the movie, he actually had a dedicated little stake thing for the question mark. That was just because he figured that there would be lots of questions. He didn't have to do that. He could have just had 0 through F, so 16 stakes, and he put in the 17th, which was the question mark, just for convenience, really. Okay, but let's pretend he didn't do that. So there it is encoded: 48, 4F, 57, 41, 4C, 49, 56, 45, and 3F. And that matches everything from the movie, well, except the question mark, right? So 48, 4F, let's look down at the table here. Oops. And remember, the 48 that I'm seeing there is hexadecimal. Okay, so here we're in our alphabet, right? And I'll scroll down as needed, right? So character number 48 hex is the capital H. And then character number 4F down towards the bottom is the capital O, and so on, right? So what was the brilliance of what Mark Watney or Matt Damon, right? Who's the genius here, Mark Watney or Matt Damon? And also, how many billions of dollars have we spent sending people to go save Matt Damon, right? Right. In The Martian, we spent billions of dollars to send. We saved Private Ryan, right? Uh, we saved him in Interstellar. We've spent just untold quantities of money saving Matt Damon. We just need to stop sending him places, right? Um, and and speaking of Matt Damon, this is funny. How many of you guys watch Jimmy Kimmel? Yeah. Do you know about their like kind of fake rivalry? So on early on when Jimmy Kimmel was on, I think the Late Late Show, he would start doing this thing right at the end of the show. That's all we have for tonight. You know, sorry we didn't have time to get Matt Damon on the show, and he was never actually there, right? But it just turned into this big joke, and as if they have this rivalry, right? And then eventually they'd have episodes where like Matt Damon is waiting in one of the dressing rooms, and then finds out he's not going to be on the show that night, and he's just like, "Damn it!" and storms off. And yeah, it's really funny actually. So um, right, okay. So how alive? So 48 is the H. Uh, 4F is the O. 57 is the W, right? Which I need to scroll down a little bit to get to it. Um, so we can see it. Okay, how, and then A, and so on, right? So the characters are encoded 1 byte each according to this table. Okay, so that makes sense. Now let me full screen this the table again, and let's look at what else is on there. So In addition to the uppercase letters, we also have lowercase letters, and those are encoded separately because capital A and lowercase a are not the same thing, right? In English, yeah, they carry the same meaning, but you guys don't type in all capitals or all lowercase. And if you do type in all capitals, right, what is it we consider that you're doing? Yeah, you're yelling or something, right? And if you do alternating uppercase and lowercase and uppercase and lowercase, then you're making a meme, right? Or mocking somebody's political beliefs, you know, right? So anyway, the lowercase letters are a separate chunk of ASCII, and you'll notice, where do they start in hex? They start at 6-1 hex or 97 decimal. Where did the uppercase letters start? 4-1 hex, and these ones start at 6-1 hex. That means the difference between them is 20 hex, which is 32 decimal. Okay, that is convenient, that two things. One, that it's a constant number, and two, that it's an easy constant number. Because it means if you want to take a lowercase letter and convert it to uppercase or vice versa, all you have to do is subtract or add 32 decimal or 20 hex. Okay, so that is really handy. So for example, let's say that you wanted to write a program that would take in a bunch of text, and any lowercase letter, it would capitalize it, right? Well, how you could do that is, if you know that it's encoded in ASCII, if it's a letter that's lowercase, you know that it's somewhere in the range from 6-1 down to whatever. Okay, so that tells you it's lowercase, and then to uppercaseify it, you just subtract 20 hex from its value and write the new value, and bam, you just uppercased it. That's it. Okay. All right, so let's keep going through the list here. And if we're using 7 bits, how many things can we encode, by the way? Well, if we use 8 bits, how many things can we encode? How many different patterns are there? 256. So if we only have 7, then it's 128, okay? And so that, now we spent 32 of them on these weird non-printable characters like the bell and line feed and whatnot. So that only leaves us with, what, 96 for actual alphanumeric characters. And then we basically run out of them here at the end. So the last 3 are the vertical bar, the curly brace, the tilde, and they're missing one for some reason. 127. Oh, it's the delete. Yeah, okay. So it's not printable. So there's everything organized in maybe a little bit more easily readable table. The ones that have the little dashes around them are not printable characters. So the first 32 of them are these weird things that have to do with transmissions and typewriters and whatnot. And then we've got the space and the delete key. And that's basically it. Okay, so this looks like a pretty good system. And it's still in use today. When you program in C, for example, everything gets encoded this way. And it certainly worked well for The Martian, right? I mean, granted, that's a piece of fiction, but like, you could imagine that actually happening. And, you know, so it's science fiction, but not really all that out of, I mean, in 30 years or 50 years or 20 years, whatever it is, we could very well imagine somebody being on Mars for a long period of time. So maybe not in the rest of my lifetime, but certainly in y'all's lifetime, I think we can anticipate that, assuming Putin doesn't nuke everybody. So, yeah. Yeah, exactly, because Putin's not there and doesn't have nukes. So, although I'm not convinced that the reliability of the Russian nuclear arsenal. So, I mean, because if it's maintained anywhere near to the level of their regular forces, then they got problems. So, all right, so great. We got uppercase, lowercase, all the digits, and plenty of punctuation. Do we need anything else? So what's the limitation of this, or a limitation of this? We can't add anything to it without, coming up with a new or an extension of the scheme. Okay, and that did very quickly happen. It was extended to be an 8-bit scheme that added another 128 characters. This is called extended ASCII, and we'll look at it in a minute. But if I need to add characters, well, that kind of assumes that there's stuff missing here. What's missing? Yeah, this is the American standard for computer information interchange, right? So because Merca, what's not in it? The ability to handle any other language besides, well, essentially American English, right? So what other symbols do we need beyond what we use in American English? Well, let's just start with Western European languages, okay? Spanish. What extra characters are there in Spanish that we don't use in regular English? Okay, the tilde. I mean, we do have a tilde, but we don't have any ability to put a tilde above. Well, where is the tilde? There it is. So we do have a tilde, but we can't do an N with the tilde above it, right? To get the, what is that letter called? Enye, right? In Spanish. Or similarly, in a lot of the vowels in Spanish have an accent mark above them. Same thing in French and I'm sure Italian, Portuguese, and so on, right? The other Western Romance languages. Uh, in French, there's the C with the little dangly bit under it called the cedilla. There's no way to do that. In something like Swedish, they have the O that has a little slash through it that is used to great comedic effect in Monty Python. Um, yeah, umlauts from German, right, where you got two dots above some of the different vowels. Not to mention there's the Greek alphabet. And for all of these, there's both lower and uppercase, right? So if we add another 128 characters to it, we're going to run out of those really quickly. Okay, so that brings us to extended ASCII, which they should have a list down here below. Oh, here we go. So let's look at extended ASCII. And there's no table. All right, so, oh, here it is. Okay, this is maybe not the most readable thing ever, but, all right, that's not very good. So let me just do ASCII table. Okay, so here are the extended ASCII codes for the last 128 bits. And what do we get? Well, we've got, starting at the left, right, C with the cedilla, we've got a bunch of the accented A's, the lowercase c, a bunch of accented E's, accented I's, capital accented A's and E's. We've got the very fun, and this is something that we hardly ever use in English, but, well, anymore, is the AE character that's kind of an A and an E smushed together to be one. We used it in Old English, but I don't think we use it anymore. And then we've got also some extra currency symbols beyond the dollar. So we've got cents, British pounds, yen. I think this is the ruble. I think that's a scripty F. Some other ones, here's the Spanish ends that we talked about, a degree symbol, the upside down question mark, right, that you use in Spanish, symbols for 1/2 and 1/4, the French quotation marks, which don't look the same way as our regular ones. And then we've got a bunch of these kind of weird looking art symbols that were used to basically make simple text boxes. They could be like borders around a box of text or something to kind of make sort of a quasi user interface. And then back at the end, we've got some other symbols that, of course, I'm very fond of. We've got some Greek letters, but not all of them, right? So we've got the ones that are commonly used in mathematics. alpha, beta, capital Gamma, pi, that's certainly important. 2 versions of sigma, mu, tau, capital phi, capital theta, capital omega, lowercase delta, an infinity symbol, phi, epsilon, triple equals, the plus minus symbol, greater than or equal, less than or equal to the top and bottom half of an integral, division symbol, squiggly equals, I think that one's the degree, dots in various places, the radical, I'm not sure what that is because I can't read it, a superscript of a 2, and then we're basically done. Okay, so great, right? We can encode Western European languages, mostly, but not Greek or anything Cyrillic. So now what? We got to add more. Okay, now at this point, we should stop just adding bits one by one piecemeal. Okay, it's time to redesign the standard from the ground up. Okay, now the redesigned standard that we use is called Unicode, and it uses it basically is backwards compatible, so ASCII fits within it, but then it adds the ability to basically have as many characters as you want. Okay, so Unicode, if we go to the Unicode website, right, is a consortium, okay, and all of the characters that you know and love, everything can be put into Unicode. Including all of your emoji. Okay, so you guys remember maybe this was a couple of weeks on Yik Yak when there was suddenly just a crap load of hamburgers going through? You know why that happened? Me, because I was talking about Unicode with my other class, okay, and I wanted to illustrate a point. We'll use something other than hamburgers today to troll Yik Yak. So every character that you can think of is assigned a 32-bit number, okay, and let's just find the code tables here. All right, so let's start with the, so ASCII is built into this, but so Latin, basic Latin is ASCII, and it is still part of Unicode. Okay, there it is, just as we described. But Latin 1 supplement, okay, is what we call extended ASCII to some, well, not completely extended ASCII, because you'll notice that we also have a 3/4 fraction. We didn't see that before. There's a bunch of non-printing things, okay? But a lot of the characters we were looking at are, of course, there. And then it gets extended, extended, extended. So what, I don't know, what other symbols or languages do you want to think about? Chinese, right? Chinese presents a real challenge here, okay, because in English or, any Latin-based alphabet, how many letters are there? Basically 26, right? And okay, like maybe if you count the accented ones, you're like in the 30s or something. And then you double that because you've got upper and lowercase. But you're talking like 50, 60, less, certainly fewer than 100 symbols to write that language, right? And then there's things like Chinese, okay? So in Mandarin Chinese, how many characters are there? Right. There are thousands upon thousands of them, right? I mean, the language is just built in a different way. So we in English or other sort of Western languages use a small alphabet and put those letters together in ways to get new words, right? But imagine if each word that you could write down had its own special symbol. And there's a little bit of method to the madness, right, with radicals and whatnot. But point being, you're going to end up with a very different structure where there are thousands of symbols rather than just 52 or whatever that you combine. Okay. Now, for basically all of us, this is sort of mind-boggling because it's not what we were taught since we were kids. If you grew up in China, for example, you would think our alphabet's weird. Like you only have 26 letters and you put them all together in these weird ways? That's strange. Okay, so where is Chinese? Well, it's all down here, okay? And East Asian scripts. And they put this in CJK, is what they call it, which stands for Chinese, Japanese, Korean. So Japanese language still uses a lot of Chinese characters in addition to two other sets of characters that are called a syllabary. So they have the hiragana and katakana. Has anybody actually studied any Japanese? No? Okay. Does anybody watch anime? Yeah. So they still use Chinese characters for a lot of things, but they have Japanese pronunciations of them rather than the Chinese pronunciations. Old Korean also did the same thing. Now, nowadays, don't think anybody in Korea uses Chinese characters for anything, either in North or South Korea. But back in the day, they did. Okay. So let's look at just the first chunk of this, and it may take a minute to load because it's 35 megabytes worth of data. Okay, and then we've got the header. 553, or 33, excuse me. All right, so Mr. Bullock, I'm going to pick on you today. Do you recognize any of these? The top left one? Okay, so there's the symbol for 1. Okay, great. What about, I don't know, how about one of these dudes down here? 4E07. This one? Okay. All right. So feng, which means to place. Okay, and I can't tell the difference between this one and this one. I'm not sure if there is a difference. Yeah. The J, yeah, okay. Well, anyway, I mean, none of us know Chinese, right? Except for Mr. Bullock. So, and you know, it's unfortunate we don't have a native speaker in this class to help us along here. But this is just one of 500 and something pages of this stuff, right? Now, these things, you'll notice they're organized in, oh, I know how they did it, right? All of everything on a particular row, these are all the same symbol, but there's different writing styles. So for example, I think in Chinese or Japanese, they would write it this way. It's basically the same symbol, but maybe it's slightly different looking. And maybe Old Korean writes it like this with that extra little thing to the side. Okay, and so that's what it is. It's just different ways of writing the same thing, and we're not smart enough to notice the differences. Because like the other thing, of course, in Chinese, and you would learn this if you took a class, you know, if you're asked to produce this symbol, right? If I asked you guys to draw that, you could all draw that, probably, if you stared at it for a minute. But what's the extra thing that you have to learn when you're actually learning this for real, Ben? Well, you'd learn what it means, but when you're drawing a character, how do you do it? Yeah, there's a very particular stroke order, and that's something that you have to also learn, right? So I could draw this, but I probably won't do it in the correct stroke order that you're supposed to use. Um, and I don't know, maybe there are differences in the stroke order in Chinese and Japanese. I don't know, right? Um, anyway, so right, so there are going to be thousands of these symbols, and they're organized here um, both based on their code point value, but also within Chinese or Japanese or Korean, there is sort of a system of organizing the characters based on certain parts that are called radicals. And I mean, I don't know how it works exactly because I haven't studied Chinese or anything. So I invite you all to go over to Dechen and take Chinese next year, and then you can come back and tell me how it all works. Okay. Anyway, so and this is just Chinese, right? What other symbols and stuff might we be interested in? Mr. Bullock, I'll pick on you again. Until February last year, you were in Russia until Putin decided to invade Ukraine, and then it was maybe not so great to be in Russia. So where is Russian in here? It's going to be in the Cyrillic stuff. Here it is, Cyrillic. Okay, and of course, it's not just the Russians that use these symbols, right? There are plenty of other Eastern European countries that use the Cyrillic alphabet or variants of it, right? But we've got that. This actually reminds me, there's a movie that just came out called Tetris. Has anybody heard of this or seen a trailer for it? So the game Tetris was actually created by a Soviet computer programmer. And in the late 80s, Nintendo really, really, really wanted to have it on their game systems. There's just a minor problem, though. In the late 80s, the Soviets were still communist, and the idea of Nintendo selling copies of this was very anti-communist, and there's a movie about that story. I haven't watched it yet, but it should be interesting. Anyway, but we've got all the Cyrillic characters, or, maybe a good chunk of them here. Okay, so we can do Russian. What else? Well, I don't know about you guys, but I have the need, very frequently actually, to be able to type in ancient Greek. I can type in ancient Greek both on my computer and on my phone. Why? Well, okay, because one of the things I do for research is look at ancient Greek math, which means I need to be able to read ancient Greek, and if I want to write about it, it means I also need to be able to type in ancient Greek. We'll get to Klingon. I do have a Klingon keyboard layout. Okay. Klingon is not in Unicode. What? Yes. In the 90s. No. Okay. In the 90s, I think this is the early to mid 90s, the Klingon Language Institute, and yes, there is such a thing, okay, decided to make a proposal to Unicode to add Klingon to Unicode. And the proposal was rejected. And at the time, it probably made sense to reject it because I'm sure Unicode was going to be terrified of like, okay, great. Now all these other nerds are going to come out of the woodwork, and we're going to have Elvish, and we're going to have Dwarvish, and whatever some dude in his mom's basement makes up next month, right? He's going to want it added to Unicode, et cetera, et cetera, et cetera. So no, Klingon is not part of Unicode. But, and here's why I think we really ought to add Klingon to Unicode. We've got all these freaking emojis nowadays. Yes, you can get a poop emoji, but you can't get Klingon. Okay, and I find this intolerable. Okay, so I don't know. Maybe before I die, my goal will to have Klingon. If we can have a poop emoji, we can have Klingon. I mean, it's kind of like, you know how everybody's butthurt about everything related to Student Senate right now and National Act and money and who gets pizza at their club and who doesn't get pizza at their other club, right? So here's my rule for whether or not something is reasonable for Student Senate to fund. If it's more reasonable than Cigar and Pipe Club, it's all good in my book, right? So, well, I mean, come on, it's cigar. They literally are lighting Student Senate money on fire and smoking it. Okay, so just saying, right? Huh? Oh, I maybe trolled them a little bit on Yik Yak. So, yeah, because I guess the latest thing is everybody's butthurt that they're going to have pizza at their thing today at lunch. And so, yeah, come for the pizza, stay for the Ponzi scheme. Or somebody else commented, I didn't know that crypto bros could trade currency for actual tangible assets. And it's real currency, no less, not, numbers that are magical unicorn farts. So if that doesn't tell you what I think about crypto, then it ought to. Okay, so there is, of course, everything you could possibly imagine and then some, right? Including a lot of things that are not actually used anymore in anything other than, say, an archaeological uh, sense. So, for example, right, where was it? How many of you guys really need to think about linear B syllabary? Huh? No, it's not Klingon. Okay. This is like ancient. Like we're talking 5,000 years ago kind of writing systems. Very, very old. The ancient Egyptian hieroglyphics, by the way, there's a code for them too. And if you're an Egyptologist, that might be really useful. Okay. Similarly, all the cuneiform stuff. So, how many of where's all my freshmen? What do we think of Gilgamesh? Huh? I don't know. And Enkidu was more dope. He got 7 days. Mhm. Well, that's the point. He was a dog. And then the 7 days turned him into not a dog. Okay. Um, yeah. So all of that writing system, it's called cuneiform because it's sort of wedgy looking things. And the wedges were made by the ends of a reed pressing into wet clay, and then the clay would dry or you would fire it, and then you would have a permanent, tablet of whatever. Um, those tablets are obviously still under very intense archaeological and linguistic examination. Um, and every time there's an expedition out in ancient what's now Iraq and Iran and kind of that part of the world, you'll find some tablet, and who knows what's on it. It could be one of the missing tablets from Gilgamesh, for all you know. So we can type that. Now, here's where the yik yak emoji thing comes in. So I used the hamburger emoji as a demonstration of this, but pick something else. Like let's take the taco emoji, or I don't know, a chicken emoji. Let's do chicken because it's Wednesday. Right? And that means that uh, it's Chicken Tenders Day in at Sparks. Is that really funny? Right? Okay. So if you type or if you put a chicken in on an Apple device, okay, how is it going to look? It's going to look like that. All right. But if you do it on, say, a Samsung device, it's going to look slightly different. Now, they're both still chicken emojis. So, in terms of the Unicode, all Unicode does is attach a number to every symbol, but it doesn't say how the symbol actually gets drawn. That's a matter for things called fonts, right? And so, even though, like, if I'm on an Apple device and I text one of you that's on a Samsung, I am going to type the thing to get the chicken and hit the chicken, and then bam, the chicken will appear, and that's a single Unicode character. And your Samsung phone will receive it, that same Unicode character, and it will display it as this chicken because that's the imagery that is built into it. Okay, so how the character looks is not the same thing as there being a code point for the character. Okay, Unicode is just basically allocating numbers for the chicken emoji will have this number. How does the chicken emoji look? That's another problem. Use the same font? That would be nice if that were standardized, but it isn't. Um, well, okay, Apple, for example, I don't know, maybe they just want to make their own versions of stuff. Okay, now where this actually has come up is how many of you guys have typed a gun emoji? Okay, what's the gun emoji on Apple? It's a little squirt pistol, right? Not an actual gun. Well, that's one reason. Maybe they can do that, and they did it because they could, right? And also, we're trying to, you know, huh? Yeah, it'll stop gun violence. Okay. Yeah. Well, don't get me started on the hamburger emoji, right? Because there's some of the emoji, some of the art, I think Google did this, where they put the cheese underneath the patty in their emoji. And this is just intolerable, gentlemen. Everybody knows the cheese goes on top of the patty. Okay. So, anyway, so Unicode in a nutshell. I will see you guys on Friday.